So picking back up from where we left off, we're going to apply momentum to Newton's second law. So we saw a version of Newton's second law previously for constant mass systems that told us that F was just equal to ma. That is to say that the force is just equal to the mass, the force on a body is just equal to the mass of the body times by the acceleration that body is experiencing. How can we relate this to momentum, and can we do something more interesting with this? Can we come up with a more general rule that applies even when this m isn't constant? And the answer is yes, and we do that using momentum. So we're going to start off just by thinking about some body, some ball or something that's being applied to having a constant force F, and it's going to have been accelerating under that. F equals ma, as we talked about before, and it's going to be initially been at a speed u and then gone up to a speed v, right? And F is constant. F isn't changing. That definitely doesn't need to be the case, as we'll see later, but just for now, F is really making this simple. F is constant. So where do we go from there? Well, what we're going to do is jiggle around with this F equals ma to come up with something a bit more interesting. So let's go back to our Suvat equations from before. We know that we've got a constant acceleration, and we know we've got a before speed and after speed, and we know we're going to say that it took t seconds to get to that point, or rather that it did that in a time of, delta t. That is to say, it's a u at t1 and v at t2. So the time taken is t2 minus t1, and we're going to call that delta t. Delta meaning change in or change of. It's just a little symbol, and we're going to just use that a little bit here. So what was our acceleration then? Well, we remember from our Suvat equations that one of the ones we can use is that a equals v minus u divided by t, right? And so here, that's in our case, that's going to be v minus u divided by delta t, where delta t means the change in time taken. But we know F equals ma as well. So F equals ma, which is just equal to m v minus u over this delta t, right? So then what are we going to do? Well, we're going to realize that we can expand this out to get that F is just equal to mv minus mu divided by delta t. But when we stop there and look at this, we realize that mv is our final momentum. This is our final momentum.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.